Hey, hello, and welcome to the show. It is me, JP, and we are all here for JP's product pick of the week. Thank you so much for stopping by. If you want to join into the chat, join the chat, get in on the chat, be part of the chat. You can head to the YouTube chat, checking that out right now. Hello to, oh wait, I have a button for that. Hunter2172-P2D, hey there. Burton R, hello. Taif, hey, nice to see you. The other place, I can't check all the chats in all of the different places that we're broadcasting, but we do have a place to aggregate all of it, and that is our Discord server. So if you want to head here, look for this live broadcast chat channel within our Discord. Hello to Blitz City DIY and C. Grover and Jim Hendrickson. Good afternoon. You can get there by going to adafruit.it/discord, and that will get you an instant invite link on over. So head on over there. Say hi. So let's see. What's going on here? I've got a new product pick. If you want to check it out, you can head over to that URL right there. You can go to that QR code. That will actually take you to a page that has two items, and both of them are product picks this week. I didn't want to put both URLs there, but if you head on over there, you should see, I'm checking it out myself as I speak, that we have 100 in stock of each, and they are half price. There's two items on that page, and it counts for both of them. So, actually, we got 75 in stock of one, 32 in stock of the other. Okay, so these are not fully stocked, but probably one will do you, but I don't know what your plans are. So go check that out. It is right there at that URL. Since this is a new enough product that we have not had a Ask an Engineer with a new segment, I don't have a video to play for you for this one. So I'll get straight to it. Let me bring up an image of it, and I can show you one as well, but this image I think makes it a little easier. That right there is my product pick of the week this week. It is the T-Mag 5273A1 and A2 3D Hall Effect Magnetometer. This is a breakout in STEMMA QT format, and you can also solder pins to it and put it down on a breadboard. I've just dropped mine. Oh, do I need that one? Where'd it go? That leapt into a void. Oh well, I've got another one plugged in, and that's the one that the demo's on. Good thing we have this image. So this is a, let me bring up some info about it. So this is a TI chip, and it is a 3-axis Hall effect sensor. So it's a magnetometer that can tell you the strength of a magnet in any dimension or any direction, any angular dimension on the strength of the magnet going across X, across Y, and up and down on Z. It is a 40, I'm going to say microteslas, I think, MT. 40 microteslas to 80 microteslas on the A1 variant. So it's a tight range on that one, perfect for small magnet moving around in the vicinity of it. And then we have the variant A2, which is 133 microteslas to 266 microteslas. Let me bring up the page for it here. There you can see the two of them are available. Normally $5.95. These are on sale right now during the show, till the end of the show. No rain checks, but during the show, these are priced to sell, so $2.98. What else to say about it? So there are 3 independent Hall effect sensors inside of the package, and they are really great for getting they're really great for things like little rotary encoders, little input devices, and in particular, you may have heard of Hall effect thumbsticks and joysticks in gaming controllers, modern gaming controllers. Some of them will suffer, that have sort of the old-fashioned style of 2 potentiometers. Those types of joysticks can suffer from what's called stick drift. If you've ever had a Nintendo Switch and some Joy-Cons, you've probably experienced this. And one of the upgrades that people recommend is getting Hall effect sensor-based thumbsticks. And I'm going to demonstrate. I've built one here, a simple version of it. But they're great because there's no real wear and tear. There's no moving parts like there are with the little wipers and the conductive bits inside of a potentiometer. So instead we can measure an XY angle using just a joystick and a magnet. This chip also, interestingly, it has a integrated angle calculation on board called Cordic, C-O-R-D-I-C, and that provides a 360-degree angular position for two axes that you pick without you having to do anything. So we have CircuitPython libraries for this, we have Arduino libraries for this, and if we go to the product page here, you can see here's a nice little demo, just reading those three axes. So someone's holding a little magnet there and they're moving it around, flipping it, changing the poles. So that'll give you an idea of the kind of raw values you get. I believe it's 12-bit values that you get off of this. And if we head to the downloads page, you can go over to the data sheet from TI, and you can see here the low power linear 3D Hall effect sensor with I2C interface, gives you some of the specs about it. And I always like to take a look at the manufacturer's application list here. Electricity meters, electronic smart locks, smart thermostats, joystick and gaming controllers, drone payload control, door and window sensors, magnetic proximity sensor, mobile robot motor control, and e-bikes. Those are some of the things they expect you might use this for. And then you can check out some of the more specifics in here, a little block diagram of how it's put together. But you don't have to worry about any of that because Limor has put together this lovely little board right here. And I'm going to give you a view of the front and back here. So you can see there's the chip right in the middle there. Stemma QT ports for plug and play. No need to solder. You can just plug that into your board of choice and off you go. And the this has a single I2C address. You can see on the back there, it lets you know it's on 0x35. So if you needed to use multiple of these, you'd need to use a couple of different I2C channels on the same board, or a multiplexer, or multiple boards. Let's see, not a lot else to see on there. There is a little power on green LED that you'll see when it's in use. And I'll go ahead and show you a demo. Go to this large view of the down cam here. And I'm just gonna refocus. So here you can see I've built my own demo unit of a 3D joystick. So I have right there's the TMAG 5273A1 magnetometer breakout. I have it plugged into a little cutie pie over here, and I'm running CircuitPython. And you can see I've taken a little quarter-inch bit and stuck a magnet on the end and used some little rubber bands and some posts here. So if you can see there, it's hovering over the sensor. If I switch views, what I've done is created a little here we go. I've created a little app, a little web serial app here that will show us the angle and the cardinal direction, as well as visualize that on a little circle. So you can see, oh, there's two me's right there. Let me get that distraction out of there. So you can see, there we go. If I rotate my little joystick around, we're getting the direction and the magnitude. I have a little dead spot in the center there that I added, so it won't, if you let go of the joystick and it's positioned, my little rubber band situation here is a little wobbly, as you can see, but it's very, very responsive and very accurate. I've got a little calibration routine I can run if I need to, but it doesn't necessarily need that each time. And that works great as a joystick. I haven't hooked this up over USB as a gaming controller, but you can see there, that's actually super smooth compared to your typical potentiometer, especially on an older gamepad. Those will get pretty rough. But this here, I can wah 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 that, and you can see it's really accurate. The code for this, I'm going to go to a simple example on code. So let me hide that view right there, and I bring Z up. There we go. So if you're going to use this with CircuitPython, all you'll do is import Adafruit TMag 5273. It doesn't matter which one you're using, A1 or A2, and in fact, it in code will figure it out. So when it instantiates the library, the board you're plugged into will check which variant is attached to it. So I'm setting up to use a couple of the built-in convenience functions, angle XY and convert angle 8x. You can see here I'm setting up my I2C bus, and then I'm setting up the TMag as sensor. Then I have a sensor.conversion average, and I'm telling it how many samples to grab, so how fast do we want it or how accurate do we want it. 8x actually seemed to work. I think the default is 32, but 8x seemed to work really well for this joystick demo. So then I have a little function here. Center angle is equal to the sum of the sensor angle for I in the range of samples divided by samples, and then I'm just printing that out. So in the main loop here, I just ask for sensor.angle, and I can ask for sensor.magnitude. I can then print those. So if you look here at the bottom, my little print statement says angle, the delta from the last one, and the magnitude. So simply asking for sensor.angle returns on two axes a 0 to 360 degree circle. And that's how that's able to do what we're doing here. Let me see if I can, yeah, I'll just switch back to this view here for a moment, and you'll see up in that upper right corner up here, can you see my cursor? Oh no, my cursor's kind of offset. But you see the little number changing up there. So it's a little bit touchy for me to get it to 0 exactly, but I'll try. There we go, just about 0, which is east for whatever reason here. And I have it, if I move my magnet to the south, I have the visualizer moving where my thumb is, and that's just because we're dealing with a joystick here, so it's actually flipped on all axes. So the magnet is heading left, but my actuator is over to the right there. Magnitude we can lift, since this is on a set of rubber bands here. I can lift that away, and you'll see that little magnitude number changing, so as I get closer and closer. But I'm actually using those in part of the calculation for the rotation there, just because the magnet moves away from center as we move this around. There we go. So let me take a look back at the chat. See, oh, I love the Wile E. Coyote. That's great. Yes, good gift. Thanks for that one, Todd. Do I have the magnet over the chip? Can you have the magnet on the back of the PCB side? Oh, that's a really excellent question. I haven't tried it. Let's do it. Let me pull my demo apart and try that. I like that idea. Or I'm just going to lift this one away and put another magnet underneath and see if that'll still give us some information. So, good question from Thin Man there. So let me go back to demo. Oh, is it not wanting to? Huh. What have I done? Oh, I know why. I've hidden it. Okay, so right there. Yeah, so I've got it far enough away that it's actually not registering those. I'm just going to grab another magnet. Hopefully this one's strong enough. And let's go ahead and just set that magnet down on the, yeah, so something is pushing it away, probably the other magnet. Let me flip it over. Oh. Try to, yeah, this is not as strong a magnet. Do I have a bigger, better magnet? I brought a bunch of them inside. Check the magnet drawer. Not really. All the really good ones. Get some from over here. I have a lot of magnets kind of all over the place. Okay, here's a stack of them. You can increase the force of the magnet by stacking a few. So this should now win. There we go. So there we are on the back side of it, influencing it, but yeah, it's not as, I'm also going through a little thing of aluminum here, so that's not ideal. Yeah, so it definitely will read from the underside. I don't know actually if there's a reason to choose one side over the other. You might just want to experiment with that a little bit if you needed to mount this in a way that you were on the bottom side. Good question. That bottom side is smooth, so if I hadn't dropped the one, oh, there it is. There we go. Let's dust that off. You can see here, backside is smooth. Let me go to. So yeah, if you put a little Kapton tape on there to avoid having to worry about any of these shorting any of these, then you could definitely mount this upside down, I think. There you go. So Starman said, I just got 2, thanks. Just pull the one off the bit first. Yeah, I should just slide that magnet off of there, or rotate that. Let's see. What if I do that? Get that out of the way. Yeah, it likes that a little better. Good call. So I think you'd be fine going on the bottom side of it. That's my guess. It is 6-axis, so they know it's got to be mounted somehow, and I think that little tiny bit of 1.6 millimeters of PCB is not really getting in the way. All right, let's see. Any other questions? John Milton asked about aluminum. This is just this little swirly grid that I've mounted this on here. Let me go to that chat. That's made of aluminum there, so that's why I have some aluminum involved. Yeah, Tyeth says, super cool, and presumably you could tap and track the Z-axis as a click. I agree, yeah, so if you're familiar with modern game pads, of which I don't have one readily available, L3 is left analog thumbstick clicked down. And I actually have no idea on Hall Effect. I don't know if I have any Hall Effect. I think I do. Yeah, I have some Hall Effect, an 8-bit Hall Effect game controller, and I'm not sure if they're using a tactile switch or if they're just having the thumbstick move mechanically and do the click, but it's actually measuring magnitude. Very good question. Bertnar says, this is a steampunk joystick. This is kind of steampunk joystick. I even thought this will weigh it down quite a bit, but I happened to have a joystick topper for a real joystick. So there we go. This is good and wobbly. In fact, if you want to emphasize the wobbly, whoa, get back here. If you want to emphasize the wobbly, this outscaled joystick topper is just the thing. There you go, though. There's a little joystick, and it's just using magnets. It's just magical. Okay, look, I think that's going to do it. Unless we have any other questions over in the chat, I'll wrap this up. And remind you, if you do want to go pick some up, head on over to that URL. I'm going to check and see. I think we've got some still in stock. We got 50 of the lower force one, the A1, and 7 left of the higher, larger ranged one. And I haven't tried out, I don't actually know what you'd use, pick those for, so you might want to poke around online and see if anyone has a favorite, but the lower range one, tighter band one is probably the one of choice if you're doing this type of thing as a little user interface. Okay, that right there, that's it. That right there is the product pick of the week this week. It is the T-Mag 5273 A1 and A2 3D Hall Effect Linear Magnetometer Breakout. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you soon. Bye-bye.